Welcome back to the channel. On this episode, I build a much needed fixture table. So unfortunately, due to space, I can't really have a very big welding table that is fixed. I do have a lot of shelving units, but I can't really weld on them, and the gas bottle is now getting in my way. So this has been my temporary solution. I used to store a toolbox on here, and this vise, it's a massive vise and it's heavy, and it's useful for a lot of things that you need to hit out and bearings and press stuff in. But on this table, it's not very sturdy at all. So the next thing we're going to move on to now is I need a fixture table. So I've gotten this laser cut. I have got a bit of leftover steel from a big project I had to do. So we are basically going to build an epic budget fixture table.
So if you're unfamiliar with what this is and asking yourself, why on earth would you want a table full of holes? Let me explain. Fixture tables come in various shapes, sizes and thicknesses, as well as various purposes. My purpose, however, to keep things flat and one or two repeat jobs. And while my man Jason over here from Fireball Tools YouTube channel builds probably some of the most epic and massive fixture tables, the purpose for mine is simple DIY use. He uses these fixture tables for a lot of repeat, high accuracy structural builds. And if you truly want to understand more about a fixture table, I suggest you go over to his YouTube channel and check it out. You can see things like how square can you actually make a square frame. But as for me, let's just get down to the basics of why I need this table and what I'm going to use it for. Basically, these tables allow you to clamp down an object flat to the surface using a clamp through the holes. This will ensure whatever object you are welding does not pull, warp or move out of position that you need it in when welding. As well as this, you can use these holes to make a temporary jig or fixture for repeat parts that do not necessarily need a permanent jig but still need high accuracy. My main purpose for this table is for two tasks. One being a custom set of control arms for Stratton's A8 project, and the other for my intake manifold for the VR6. I'd like to keep a high level of accuracy for the control arms while repeating the process a couple of times. I hope my explanation made sense, and if it didn't, it's fine for you to watch anyway.
So obviously on my bandsaw episode, I did let you guys know that I'm struggling with blades breaking. So I've gotten one more set of blades. I did get a quote from another company which is double the price for the same blade. I'm going to try this company one more time and then we go from there. So what we're going to do now is fit the blade and let's see how many cuts we can get out of it before it breaks. So this is the rectangle tubing I'm going to use for the base of the fixture table. It is that, I think, 6 or 8 millimeter thick industrial grade rectangle tubing. So because I've changed back to the TPI that I used, that other blade that I was using was an 18 TPI, but for whatever reason it doesn't break. I don't know if that has to do with less tension on the blade because of the teeth, I'm not sure, but what I like to do when I change TPI is basically just do a calibration cut. I like the bandsaw to cut as accurately as possible. So let's do our calibration cut and then we start building the fixture table. Cool, so the calibration cut is done. Just by eye I can tell that this was pretty much dead flat. So what I like to do, pull it out. Grab square and then and basically just check how square we are. And I mean, that's within a millimeter. So I'm super happy with how this little bandsaw cuts. Let's check this way. This square is a little bit long, but I mean, that's so close. I'm happy with that.
Starting off, a visit from health and safety as well as quality control was needed. Once that was done, I moved on to start doing the outer reinforcement plates. Using 5mm thick 50mm flat bar, I built a frame on the outer perimeter of the table. Basically what this does is keeps the table straight and keeps it from pulling. Once I had finished tacking on the outer perimeter, I then moved on to the inner brace. The inner bracing keeps the table rigid as well as adding a little bit of needed weight. Next up on the to-do list was fitting up the legs as well as plates to hold the caster wheels in place. Next up was flipping the table around, only to realize I didn't take the caster wheel height into consideration when cutting the legs, and then contemplating throwing myself off the top of the table before having to cut the legs off again and redo it. Once I got the legs to the right height that I was happy with, I then fully welded them and grinded them down on the sides nice and clean, ready for paint. To keep the frame as rigid as possible, I welded a support on each side as well as one across the center of the frame.
Okay, so we're about halfway done building the fixture table, and to my surprise, the blade is broken. I think there's about 8 cuts on this steel that the blade went through, so yeah, I don't really see that as efficient, because none of the teeth, get it to focus, none of the teeth are even broken off. The blade still looks brand new, but there's the end, and it's 100% broken on the weld, so I think it's time for a new supplier.
A little bit of thinking had to go into whether I wanted the welder mounted on the table or on a separate movable trolley, but due to space I decided the first option would suit me best. Once I was happy with the position of where the welder was going to be on the frame, I then whipped out the trusty old drop saw and got some 50x50 square tube and reminded myself why I hated this machine in the first place. After I had done throwing sparks everywhere and making a loud noise, I then had a base to weld onto the frame for the welder to stand on.
Alright, so we've gotten the main frame of our welding table done. So the next thing that I want to move on to is what I want to do with this gas cylinder. Because the table is now movable, dragging around the gas bottle just doesn't make sense. So I think what I'm going to do now is basically make 2 mounts so that the gas bottle is easy to put on and take off. So let's see how well that goes. So I've got quite a bit of cut-offs from making the frame and the previous frames that I had to make. So what I'm going to do is basically get the same radius as the gas cylinder and just notch it out and notch it out on both of them, and then mount one over here and another one on the bottom side, and then have 2 chains to connect them, and then a base for the gas bottle to stand on, so that makes everything easy and mobile. Alright, so we've got the gas bottle mounted. I'm pretty happy with how that came out. That was quite a mission. It was a bit touch and go on whether I was actually going to do it. I am a little bit concerned about these castor wheels. They were just some cheap ones from Galmar, but I don't know how much load that they can handle. They are quite cool because they lock the wheel and they also lock the direction when you lock it, so it doesn't turn, because they are got all four directional wheels. So yeah, we'll see how long those last, but for now I'm now going to move on to mounting the vise, and then I think it's paint and I'm done. So let's carry on with that. Alright, so I'm pretty happy with how the vise mount has come out. I thought once I was done with that mount I'd be done and start painting, but one other thing came to mind. So with TIG welding, which is the only thing I'm going to be doing on this fixture table, the MIG splatter gets everywhere and it destroys the surface of your table. So with TIG welding, you want your filler material that you add into your puddle as clean, as moisture free, as dust free as you can get it. So a lot of guys sell storage containers and all that kind of stuff for your filler rods. What I basically do is I use some PVC pipe and store it in there, especially with aluminium filler rod. The aluminium stuff oxidizes and picks up moisture and then gets terrible black pitting and stuff when you try to weld with it. Just basic dirty rod. So I use the PVC pipe. So I've had these ones before, and the problem is I've just made the tube a little bit too short. So as you can see a little bit earlier, the lid just pops off and can't tighten down. So I'm going to make a new set, and what I used to do was just use a PVC pipe mount, but those plastic things just break off all the time. So I'm going to continue on with the theme of reusing scrap and leftover metal, and use this as a mounting plate on the side here, and then I'll also show you guys how to make a nice little very cheap filler rod holder. So I've been working on the TIG storage holders. So I basically finished making this piece to hold the PVC pipe. That was chaos. This 8mm thick plate to drill through and just use a hole saw on this so thick and hard steel. Took forever. My drill press took a lot of strain, but in the end we got through it, and I'm pretty happy with how this has turned out. So now I'll weld this on, and then we start piecing together the actual PVC pipe. So this is basically how the tubing is going to sit on the side. These are the end caps, so we'll have mild steel, stainless steel, aluminium. So let me tack that on and we can start piecing everything together. Alright, so before I fit the filler rod tubes, when I had the gas bottle on and I was moving the table around, surprise surprise, the caster wheel decided to explode. So the wheel itself seems to handle the load on this Galmar brand, but the bearings just cucked itself, and so that's pretty useless. Then I got another Builder's Warehouse special thing. It's pretty much identical, but the only thing is this is plastic, and that didn't even last putting the gas bottle on. So this moved around, and then bearings just the other one, the wheel is completely just squashed. So can't have that when I need to move this thing around and put it away when I'm finished with it. So I found these, and the sad part is these are the same price as these. So this, if you put them next to each other, you can see the difference in just bearing size and wheel size, as well as these have nylon wheels with bearings on the inside of them, and it also has the brake and the directional lock, but you can feel that these things are proper, and the load rating for these are, I think it was 150 or 200 kgs per corner or per wheel, so I think that's plenty for what I need it for. So the flanges are a little bit different, so I'm gonna have to figure that out, but I'm gonna just quickly swap these out and put these on before finishing up with the TIG filler rod holders, and then we are pretty much almost done. Alright, so if you've worked with PVC pipe before, you'll know what to do in this part, but for those who haven't, I'll explain. You'll need a PVC cement. I use low pressure because this isn't handling any pressure and it's cheap. You can use the heavy duty or high pressure stuff. It will keep the tube together forever, but yeah, this is like, I think, $200 a jar, so it doesn't really make sense if you're making 3 of these things. So what I'm going to be doing is basically making these tubes fixed in here so that they don't ever fall out, or if I move it around I don't have to worry about these things bailing out of the cart or whatever. So what I'm going to do is start by putting the caps on, getting my lengths, and then going from there. So let's start. Okay, so you want to get a decent amount of the PVC cement on the inside. And then get it to sit as flush as you can. Obviously you don't need to color the tube. I'm coloring them because I like stuff to look neat, but you guys obviously don't have to do that. Also note that the PVC cement will char your paint like it did over here for me, and then just clear out any excess on the inside.
Once you have placed your threaded part for your cap onto the PVC tube and then sealed it off with the solvent, the next step is for you to measure the total length you'll need off of a TIG filler rod, and then cap it off with a end cap, and once you seal it with the lid, you have a complete sealed unit. I, however, am going to make mine non-removable, so I'll first measure everything, cut it to length, and then cap it off so it cannot be removed.
And that's the fixture table done. I am super happy with how it's come out. Honestly, for the budget and for what it is, I couldn't be happier. These caster wheels as well have just made such a difference. These heavier duty ones, everything just moves as it should. Even with all this weight on it, I can just freely move this thing around. So I'm very happy with this. We are going to call it the end of this episode here. So I hope you guys enjoyed this. The next episode, we obviously will be carrying on with the Audi. I'm sort of breaking up the DIY stuff in between building the Audi as I gather parts or source budget and that kind of stuff. So in the next episode of the Audi, I've got a wastegate, got all the flanges I need to build the intake manifold, and that was obviously the main purpose for having this, so that I can bolt all these flanges square down to the fixture table, and then from there mock up and design how I'm building this plenum. So if you guys enjoyed the video, please like, share, subscribe and comment. A little goes a long way, and I really appreciate you guys watching. I'll see you guys in the next one.